A hammer or mallet is a fundamental tool for a maker, and most of us probably have a fair few of them. I don't have a huge collection, but here's a few of them, and they're all used for different tasks. One hammer I don't have is a brass hammer, so in this video I'll make one that I designed in Shaper 3D. I've got a piece of brass round bar, so I'll cut a piece off that and I'll get straight into it. I'll face both ends first and get it to the correct length. I'll be turning the hammerhead between centres, and because I'll need to drill centres to mount it, I'll cut a couple of sacrificial discs that I'll glue onto the faces. I've sanded off the nubbings left from parting them off, but the opposite sides have been turned down flat before they were parted off, and they'll be the sides that will get glued. I'm pretty confident these should hold on the lathe. The main thing I need to look out for is not getting too much heat into it while turning it. Next, I'll drill the centres ready for mounting it. The disc is slightly off centre, which doesn't matter, but the bar needs to run fairly true, as the brass I have is only slightly larger than the final dimensions of the hammer. To drive the workpiece when mounted between centres, I made this crude drive dog, and the spigot of that will contact one of the jaws of the chuck and rotate the workpiece. The drive dog is only made from aluminium, but I have already used it on this test hammerhead I made a couple of months ago, and it worked well. I've put a dead centre in the chuck, and I turned that down with a light cut to ensure that it's running true, and now I'm mounting the hammerhead using the live centre in the tailstock. The first thing I'll turn is the fullers either end of the hammer, and I'll try out this carbide cutter and see how that goes. I'll set the face of the brass as my 0 point, and I'll reference everything from that, and I'm using a cutter with a point in the centre of the holder which matches the centre of the round cutter that I'll be using next. That's not cutting as well as it did when I made the aluminium test hammer. The lathe is running too fast, but I did try it out at a few different speeds and it was no better. Next I'll try out this high speed steel cutter and see if that's any better. It is working much better, but it's a bit grabby, so I've decided to cut a groove in the centre of the fuller using a parting tool and then see if that helps. One way or another I will get there, even if I have to file it. The groove will also give me a depth guide of where to cut the fuller to. That's working much better, and I'm trying to feed the cross slide as slow and smooth as I can, but it does still grab a little now and again. As I'm getting towards the end, the tool is cutting a bigger area and it's grabbing a bit more, so I'll stop at that and I'll finish it from there with a bit of sanding later on. If you click the link in the description, I'm excited to announce the release of 200 of the same Pask Makes brass hammer that you're watching me build in this video. In conjunction with expert craftsman JT Belknap from DFM Toolworks and Liam Hoffman from Hoffman Blacksmithing, we've made available these 200 brass hammers that I've carefully designed, just like the one you're watching throughout this video, with its premium head and high-end hickory handle. If you'd like to order yours while they're still available, simply click the link in the description before they sell out, and as always, thanks for your support. I reckon the fullers look great, so next I'll turn the middle section into a barrel shape. Using the 3D model on the computer, I've worked out at the centre line, which is 45mm from one of the faces of the hammer, the radius will be 21.9, and 40mm across it will be 21.75, and so on. There'll be a series of steps, and then I'll just use a file to file those smooth. I'll take light passes until I get a full cut all the way across, and then I can take a measurement from it. Now I can measure the diameter with my calipers, and I can put that into my DRO and then halve the x-axis for the radius, and from there I can input the radius of each step. First I'll take the whole section down to the radius of the centre position, then the next cut will make the first step after I've moved the cutter in using the reading on the DRO. I'm using the power feed but stopping a little short and finishing the cut with the hand wheels. That was easy enough. The hardest part was figuring out the radius at different positions, but actually that was pretty easy to do too using the 3D model. I'll file this half now while it's easy to access, and I did think about cutting the other end first and then filing the whole thing, but I'd be getting pretty close to the drive dog and this way will be safer. It's a fairly subtle curve and it should look even better when the other end is done, which I'll do next. It's beginning to look like a hammer. Next I'll turn down the ends and then cut some chamfers on these edges. I'm using a 60-degree cutter either side of the fuller and then a 45-degree cutter on the outside edge. And as with all the other steps, I've put the drive dog on the other end and repeated it. I'm just judging the chamfers by eye and matching them to the other end. Next I'm adding some rings to the barrel section, and these are just for looks, but hopefully they should look pretty cool. I come across to the correct position, then I'm touching the tool onto the hammer. I then zero the x-axis and then I can cut a ring to the depth that I want, reading the DRO. Starting with one of the middle rings, I cut that to a depth of 0.9mm, and then each ring afterwards gets slightly more shallow, which should leave a subtle but nice effect. I then go through the same procedure for the next ring and then so on. I'm super happy with how they look. Next I'll machine the cheeks of the hammer on the milling machine. I've got each end sitting on parallels. I'll mill one side with the height gauge set and then flip it 180 degrees and mill the other end to the exact same depth. To ensure the two opposite cheeks are parallel to each other, I'll use an adjustable parallel underneath the first side, and that will set it level, ready to cut the other side. That went very well. Now I'll drill the eye ready for a handle. First I'll use an edge finder to locate the centre, and from there I'll remove some material by drilling a couple of holes from each side, and then I'll mill out the eye afterwards. Next, I need to taper the eye into an hourglass shape ready for the handle. I thought about machining it, but by the time I set something up, I could already have it done with a file. It took about a quarter of an hour, and I reckon that should work. To finish the eye, I'll neaten the edge by filing in a chamfer. There's one more feature to go, which is another chamfer where the rings meet the cheeks. This really wouldn't be easy to machine, so again I'll do it by hand with a file. I'll set the angle of the cheek to 20 degrees and then try and keep the file level by using the vice jaws as a guide. Then it's pretty easy to keep the chamfer a consistent width just by eyeballing it. That was easy enough to do, and I reckon the chamfers finish it off nicely. Next I'll sand the faces ready for etching on my logo. I'll clean off the glue with acetone, and while I'm at it, I'll clean down the whole hammerhead. Now it's ready for etching, and for the resist I'll use vinyl. I'll transfer the whole vinyl and then weed off the areas that I need to directly off the hammer. I haven't tried this before, but someone told me to try this method. Sorry I forgot who you were, but thank you anyway. In the past, when I've weeded it first before transferring it, some of the very small pieces of the design come away, so I thought this method was worth a try. The etching surface is facing down, which is the ideal position. This is my preferred solution for etching, and I've had fantastic results from it. I mix it 5:1 with water and keep it at 70 degrees C. Every so often I take it out of the etching solution and brush it to expose a clean surface ready for the etch to do its thing again. It's been 2 hours, so I'll take it out and rinse it in water to stop the etch, and I'll take a look at it. I didn't tape it as well as I should have, and some of the etching solution has leaked. It's not that deep at all though, so it will be easy to clean up. I could have spray painted the rest of the hammer for the resist. I thought about it and I probably should have done that. I'll clean off the pink areas and get it looking back to normal again. I didn't check the etch often enough, and the last part of the process has aggressively etched in the logo, leaving some deep pitting. This has never happened before. It could have been worse, but I'm still disappointed. And there's the pitting. I'll leave it for now and have a think about what I can do. Anyway, onto the handle. I'll use spotted gum, but if you get hold of one of my limited run hammers, the handles made by Liam will be hickory. Hickory isn't the easiest thing to find in Australia, and spotted gum is the handle material of choice. I'll round over the end, which will eventually become a dome. It's something I really like and I use on most of my handles, and this will be a good starting point to finish it from. Next, I'll hot glue one of the waste pieces back on, attach the other template and cut it out again. Before I shape the handle, I'll fit the head first. Once the head will go onto the handle, it's just a case of refining it until it goes on all the way. You can see the shiny burnished areas where the handle fits the hammer, so I leave those alone and take off the material further down. That's a good tight fit, so next I'll shape the rest of the handle. I'll mark where the head stops so I know not to go past that. You could use a spoke shave, draw knife, or even just a regular knife to start shaping, but the saw rasp takes off material fast and you don't need to worry about grain direction. Also, a belt sander would be great, but it's dusty and I find this more enjoyable. That's starting to get there. Next, I'll work on the domed end. I'm just doing this by eye until it looks right and I'm happy with it. To get the transition between the end and the rest of the handle, I go back and forth, refining each of them until I get what I'm looking for. Before I fit the handle, I'm going to try and remove the pink that's in the logo of the hammerhead, and that's the copper content of the brass showing through, and I'll remove that with hydrogen peroxide and vinegar. That works really quickly. It was only in there for a few minutes, and when I took it out I was a bit worried what I'd done to the whole thing. I cleaned it back up with wire wool and I reckon it looks great again. It looks like it has a very slight patina, which I like, and the logo looks much better. It's not perfect, but I think I can live with it now. I could paint it, but that wasn't something I ever really wanted to do. Next, I'll fit the handle. I'll make a cut for the wedge, and that will be at around 2/3 to 3/4 of the height of the hammerhead. To finish the handle, I'll use boiled linseed oil. I'll try it out with a bit of chisel work, and I'll cut a random pocket out of this scrap piece just to see how it feels to use. It's fantastic with a really nice weight to it, giving lots of control, and it's a pretty cool looking hammer too, if I'm allowed to say that. I'm super happy with it, and I reckon it turned out awesome. I'll use one of the hammers for chisel work and general woodworking, and the other will be for use on the milling machine. If you'd like to get hold of one, check the link in the description if there's any still available. I need to give a big thanks to JT and Liam for working with me and putting up with me. Hopefully you enjoyed the video. Thanks for watching, and I'll see you on the next one.